Exercise 3D question number 1. So this is mass F, and then we need to do the histogram. So then class width is going to be 5, 5, 15 minus 5, 10, 20 minus 15, 10, 5, 5, and 5. And frequency density is going to be 4 divided by 5, which is going to be 0.40 divided by 8. So 12 divided by 5, this is going to be 2.4. Basically 0.8, 12 divided by 4, 24, 23 divided by 5, 4.6, and 8 divided by 5, 1.6, and 3 divided by 5, 0.6. So now we can draw the histogram. This is class width M, and this is frequency density. Ten to 15 is going to be 0.8, so somewhere here 10 to 15. Then 15 to 20, 2.4, 2.4, some 2.5, 2.4, somewhere here. And then 25, 4.6, 20 to 25, 4.6, somewhere here, 4.5. And 1.6, 25, 30, 1.6, 1.5, so 1.6, somewhere here. And the 0.6, this is 1, 0.6, somewhere here. So this is the histogram. Please write frequency density. And then we need to draw the polygon. So we'll take the middle place, and then we'll merge. Question number 2A. Some students take part in an obstacle race. The time it took each student. So it is the time each student to complete the race was noticed. The result was shown in the histogram. Given reason to justify, use the histogram to represent this data. Yes, for a histogram, it has to be grouped continuous data. So grouped continuous data. So we have time. So time is a continuous variable. Part B, 60 to 70. 60 to 70. The number of students in 60 to 70 is 90. So in this area is frequency is 90. So what is the our equation? Frequency density class width equal area equal frequency. Now I can see that there are small boxes, lot of small boxes. So we have to count how many boxes are there. Well, 1, 2, 3, 4. Likewise, when you count from this diagram, 60 to 70, you will get around 60 boxes, 60 small boxes. So 60 small boxes represent 90. So one small boxes 90 divided by 60. This is 3 over 2. And then we need to work out, find 40 to 60. So number of boxes in 40 to 60 are, um, when you count you can see that 100 small boxes, 100 small boxes. Then 60 box is 90, one box is 90 divided by 60, and 100 box is 90 divided by 60 multiplied by 100. It, so it's going to be 150. Part C, find the number of students who took 80 seconds no less. So then the boundary is going to be 40 to 80. So in this class interval, so we need to find number of small squares. So there are, when you count, you can see that 246 squares. So then one square is 90 divided by 60, and 246 is 90 divided by 60 multiplied by 246. So this is going to be basically 1.5 times 246, 369. Part D, calculate the total number of students who took part in this race. So in that case we have to 40 to 120 interval, we need to calculate number of squares. So there are, how many, when you finish 466 squares, and number of employees, number of students, uh, this is the ratio 3 over 2 multiplied by 466. One box is 90 over 60. 466 power is 90 over 60 multiplied by 466, which is going to be 699. Question number 3 is going to be the same one. A fun day committee at a local sports center organizes a throwing racquetball competition. The distance thrown by every competitor was recorded. The histogram showed data. The number of competitors who threw less than 20 meters was 40. So the question number A is standard question. Why is the histogram suitable diagram represent the data? So we want to check the variable is continuous. Yes, the distance is a distance is a continuous variable. This is one requirement. And part B, um, area equal frequency. So width divided by class width. According to this one, 20 meter, less than 20 meter, it means 0 to 20 interval. There are 40 pupils. There are 40 people. So 0 to 20, how many small squares there? You can see that there are 50 small squares. 50 squares small. So represent 40 people. Then one box represent 40 divided by 50, which is 0.8 people. Now, how many people enter the competition? So how many total number of squares there? So when you count, you can see that there are 387.5 squares there. Then the area is 0.8 times 387.5. So this is going to be 310 people. So 310 people into the competition. Estimate how many people throw in between 30 to 40. Same sums. 30 to 40 number of squares. Uh, the number of squares in between 30 to 40 interval is going to be 93.75. So one square is 0.8. So 93.75 square is 0.8 times 93.75 equals 75 people. Part B, how many people? 45 to 65. For, there are 45 to 118.75 squares in between 45 to 65. Then one square represent 0.8 people. Then 118.75 box represents 0.8 times 118.75. It is 95 people. And part A, estimate how many people through less than 25 meters or less than 25 meters. There are 81.25 small squares in less in between 0 and 25. Then 0 1 square represent 0.8. Then we need to know 81.85 represents 0.8 times 81.85. Sorry, it is 25. The answer should be 65 people. So you have to count these small squares very carefully. Question number 4. The farmer found the masses of a random sample of lambs. The Matches were summarized in the group frequency table and represented by the histogram. The frequency is given. So in between this interval, 28 to 32, there are eight. There are eight. Sorry, it is 32. 28 to 32 interval. There are 32 lamps. Uh, in this area, 23 to 8 area, there are 100 squares. Uh, in 28 to 32 uh, class interval. So this 100 square represent the frequency is 32. So area and the frequency FD multiply by class W class width. So we'll stay with this side. So 100 represent 32. So it means 100 represent 32. Then 1 square represent 32 divided by 100. Now part A, 25 small boxes. So 25 small squares. I will write box is more practical. Represent 72 divided by 100 multiplied by 25. It means 32 divided by 4, 8. So part B, find the frequency of 20, 24 to 26. So 24 to 26, there are 100 squares in 24 to 26 interval. It means we know that if it is 100 squares, it is just 32. Part C, number of lamps in the farm. So total number of squares is so total number of squares is 0 to 2400 and 24 to 26 it is again 100 and 26 to 28 we have small 200 boxes and 28 to 32 we know that is 100 already and 32 to 34 we know it is going to be 5 times 5 25 so 525 so then one small box represent 32 out of 100 then 525 boxes is 32 out of 100 multiplied by 525 answer is 168 lamps. So part D we want to calculate 25 to 29 number of lamps in between this interval. Uh, First of all, we'll count the boxes 25 to 26. There are 50 boxes and 26 to 28. We already know that 200 boxes and then 28 to 29, it's going to be 25 box. So total number of boxes in between this interval is 275. Uh, one boxes represent 3200 frequency. So 275 boxes represent 32 divided by 100. 275, that is going to be 82 lamps. Uh, there are 82 lamps in the interval of 25 to 29. The interval of question number 5. When you look at the histogram, we can see that um, area and frequency, um, 0 to 20, their frequency is 4. So number of small squares is going to be 1, 2, 3, 4, 5. Question number 5. 0 to 20. There are 4 boxes, 10 small squares represent 4. So 10, so 1 boxes represent 4 divided by 10. Now 20 to 30, how many boxes there are? There are 25 boxes in between 25 to 20 to 30. Now then 25 boxes worth is 4 divided by 10 multiplied by 20. So this is going to be 10. So this value is going to be 10. 40 to 50. Again, I can see 40 to 50. There are 17 5 boxes. One box represents 4 over 10. 17.5 boxes, 4 over 10 multiplied by 17.5. This is going to be 7. So this value is 7, and 50 to 70. There are 15 boxes. So one box is 4 over 10, then 15 boxes is 4 over 10 multiplied by 15. That is going to be 6. And now we'll work out the same sum with this side. If we know the FD times class with equal frequency. So frequency density for this one, you can see that that is 1, and class width is 10, 20 minus 10. So this is going to be 10. And then frequency density for 40 and 50. 40 to 50, the class width is 0.7, I can see. 0.7 times frequency density. 0.7 times 7 is 7. So this is going to be 7. And the other one, 50 to 70, the density is 0.3 times class width is 20. This is going to be 6. So we can come that way around as well. Class width is going to be 20, 10, 5, 5, 10, and 20. Frequency density, you will get that 0.21. 10 divided by 10, 1, 15 divided by um, 15 divided by 5, 3, 25 divided by 5, 7 divided by 10.7, 6 divided by 20.3. So then we can draw a histogram accordingly. So 0 to 20, this is 0.2, then 1, 2, 3. So this value is going to be 0.7, 0.3, and 0.7. So this is 0.3 and this value is going to be 0.7. Now the last question is going to be uh, estimate the number of passengers in between 25 to 38. So 25 to 38 number of passengers. So in that case 25, then up to whole this one, half of this one, and 38. Now 25 to 30, 20 to 30 represent 10. That 10 less than represent 10. This 10 with represent by 10th. Then 1 represent by 10 over 10th, and we need 5. 5, it's going to be this 25 to 30th. 5, 10 over 10 times 5, 5. It means, in other way, it is reasonable that whole area represent 10. So half of it 5, 5 each. And we know this is going to be 20, 30 to 35, 15. And then 35 to 40, that is 5 area represent class with 5, 25 people. So one area, one class with represent this one, 5. Then 3 class with 35, 36, 37, 38, 3 represent 5 times 3, 15. So this is 15. It means 5 plus 15 plus 15, that is going to be 35. So answer for part B is this. And question number 6, part A. Write down the class boundaries for 13 to 14. When you look at, you can see that the class boundary, there is a gap. 11 to 13, there is a gap, and 14 to 15 gap. So we know the technique to get rid of gap, adding 0.5 and taking 0.5. So I wrote now, so this class interval, earlier it is 13 to 14, now it is 12.5 to 14.5. Part B, uh, find the width and the height of the, right. Part B, we have an equation, frequency density multiplied by class width, alright, width or CW equal area equal frequency. Now they are telling 13 to 14. this one 12.5 to 14.5. Basically they have height is 6 centimeter and the width is so 6 times 4, and frequency we know 24, and class width we know this is going to be 2 14, and the frequency density we can find 24 divided by class width. So class width, this is 2, so 24 divided by 2, uh, frequency density 12. So those are the relationship I can see. On top of I can see that 12 FD frequency density we show by 6 centimeter. That is also important. 2 class width we imply by 4. So this is also because now this is not just a square. So it has a different size of squares now. We'll see that what kind of a square is going to be. 12 represented by 2. 12 FD represented by 6 centimeter. Then 1 frequency density 6 by 6 divided by 12, 0.5 centimeter. So height of one unit is zero point 0.5, and this is 2 and 4. 2 class width represented by 4 centimeter. 1 class width represented by 4 divided by 2 centimeter. Then this box says 2 centimeter long, zero point 0.5 height. So that is, this is going to be, okay, this is 2 class width. Yeah. So 1 class width is 2 and 0.5. So this is the ratio basically, just to say. Now the question is 15 to 17. So 15 to 17, what is the frequency? 14.5 to 17.5 frequency is 18, and we need to find those two. So what is the class width now? Class width 17.5 minus 14.53. Okay. Class width 3. When the class width is 3, so if it is 1, 2 centimeter. If it is 3, this is going to be 6 centimeter. So 3 class width is 2 times 3, 6. Now, since we know the class width 3, we managed to find the height. But do we know that the FD, frequency density? Yes. The frequency density is 18 divided by 3. So then 18 divided by 3 frequency density, which is 6. So then we know one frequency density is 0.5 centimeter, and we need 6 frequency densities. 0.5 times 3, which is 6, which is 3 centimeter. So this is height and this is width. That's how we start with, right? 6 is height. Now height and width. So then width is 6 centimeter, height is 3 centimeter. So width is 6 centimeter, height is 3 centimeter. See that I easily look at the relationship with this. So there's one small learning here. Area earlier, it was is one single box I use. In this box, length and width both same. But here they change the length and the width. So the box size is this one, zero point 0.5 and 2 centimeter. So one freedom frequency density is zero point 0.5 and this is 2 centimeter the length. So in kind of situation you want to get the ratio. Now from here the given data, this is given 2 class width represented by 4. So 2 class width represented by 4. Then 1 class width represented by 4 divided by 2, which is 2. Then 3 multiplied by 3. 2 times 3, 6. The same way here 12 class freedom uh, frequency density represented by 6. 12 represented by 6, 1 represented by 6, 12 by 2, zero point 0.5. 0.5. Now here I can find the class width because I know that this they are referring 14 to 17, 15 to 17. So class width is 3. Then if I know this one, I can find this value like this. From this ratio 2 to 4, then what is 3? 3 to 6. Then if I know the frequency density, then here then I can get this ratio. So what is the frequency density? 18 divided by 3, 6. Then 12 to 6, then 6 to 3. 12 to 6, then 1 frequency 0.5. Then 6 then 6 FD is 0.5 times 6, which is 3 centimeter. 6 FD is 0.5 centimeter. So sorry, 1 FD is. Then 6 FD is 6 times 0.5, which is 3 centimeter. That's why it is important. A lot of students say that they can't understand what is going on. So when you have this equation, frequency, this one equal area equal frequency, you can handle that. Earlier area I wrote in a small boxes. Now area, height times HEIG, height times width. That is the scale given. So height is 6 and this one is 4. Before I start 7, so just one more summarizing of number 6. The 4, 2 class width and 16 FD represented by 4 and 6. Now we want to find 3 class width and 6. So basically 12 to 6, then 6 to 1, 6 over 12, then 6 is 6 over 12 multiplied by 6. This is 3 centimeter. And 2 represented by 4. 1 represented by 4 divided by 2. Then 3 is represented by 4 divided by 2. That is 6. So this is 6 centimeter. That's the sum. Question number 7. Part A. 8 to 10. So class width is 8 this is continuous for 8, 8, 10, so we don't need to do anything. So 10 minus 8, the class width is 2. So 2 class width, and frequency density is frequency divided by class width, 8 divided by 2, 4. 4 ft, 4 ft represent by width 1 centimeter. So 1 centimeter width and 8 centimeter height. Now we need 11 to 12. 11 to 12, 1. 1 CW, because class width is 1, 12 minus 11, 1. And now I need the width density. So frequency divided by class width. So this is going to be 7 FD. So 4 FD. So this is going to be 7 FD. Now we'll find the ratio. 2 class width represented by 1 centimeter. So then 1 class width represented by 1 divided by half a centimeter. So this is going to be half a centimeter. Now 4 frequency density divided by 8 centimeter. 1 frequency density by 8 divided by 4 centimeter. Then how many we need? 7. So 8 divided by 4 times 7, that is 14 centimeter. So this is going to be 14 centimeter. So now it's done. In here you want to find the width and the height. So you should know class width and frequency density. Class width minus and frequency density also divide 7 divided by class width. So now next question is mean and the standard deviation. Uh, so summation f is going to be 4 plus 8 plus 6 plus 7 plus 5 plus 1 equal 31. Summation fx is going to be 4 times 6 plus 8 times 9 plus 6 times 10.5 plus 7 times 11.5 plus 5 times 13.5 plus 1 times 15.5. So summation fx 322.5 and summation fx square is going to be 4 times 6x square plus 8 times 9 square plus 6 times 10.5 square plus 7 times 11.5 square plus 5 times 13.5 square plus 1 times 15.5 square. So this value is going to be mean is x by summation f x over summation f, that is 322.5 divided by 31. This is going to be 10.4, and the standard deviation is summation fx over summation f minus summation fx over summation f, and this is x square, and this is square root. So we will get this one 3530.59 over 31 minus 10.4 square. So this answer is going to be 2.4. So now we need estimate for lower quartile. So frequency, cumulative frequency 4, 4 plus 8, 12, 12 plus 6, 18, 18 plus 7, 25, 5 plus 30, 30 plus 1, 31. Now Q1 equal 31 divided by 4. That is 7.7 fifth term. So that term is 4 and 12. In between 4, it is not here. Actually, it is in this group. 4, 5, 6, 7. So basically, one boundary is 8. The other boundary is 10. Now I need as, okay, that's also wrong. Oh, that's fine. The frequency here is 4 and the upper bound is 12. So this is going to be 7.75 we need. When it is 4, what is the frequency? 8. And when it is 12, it is going to be 10. So we need this one. So this is Q1. So Q1 minus 8 over 10 minus 8 equals 7.74 over 12 minus 4. So Q1 equal 9. Just to clarify again, so we need 7.75 term. So up to here 4. That term is not in this one, 4 to 8. The term is in this class interval, 8 to 10. So we can find easily the 10 boundary is 12 and the 8 boundary is 4. So that's why I always 4 to 12 and 8 to 4 to 12, 8 to 10. 5, 6, 7, 8, 9, 10, 12 in this journey. And that boundary is changing 8 to 10. Instead of taking 8 to 10 here, I usually take from here 8 to 10 because then I can get the right boundary 4 to 12 without any mistakes. But actually, this is the class interval we need. Because 7.75 in this one, and then it should be in this 8 and 10. So up to 10th it is 12, up to 8 is going to be 4. Part D, x bar is 10.4, so x bar plus sigma equal 10.4, 2.8, so this is going to be 12.8. Now we need the 12.8. 12.8 terms is lies in here. Not up to 12, 12.8 is in between. Uh, 12 and 15, we need 12.8. When it is 12, what is the boundary? 25. When it is 15, what is the boundary? 30. We need which terms is this one? Say temperature. So this. So then we'll write the interpolation 12 to minus 12. Actually, I'll start with this one, this side. D minus 25 over 30 minus 25 equal 12.8 minus 12 divided by 15 minus 12. So D value we will get 26.33 30 days. Up to here it is 33 26.30 days. Up to total it is going up to 31. So this distance is 31 minus 26.33. So that is 4.67 approximately, let's say 4.7 days.